Hi students, this is Mr. Halpern. In the second video on air pollution, we'll be discussing a bit about ozone layer depletion, as well as acid deposition or acid rain, and then we're wrapping up with indoor air pollution. We'll talk about the ozone first. So the ozone layer is extremely important for protecting us from UV radiation from the sun. But in the 1980s, scientists discovered that there was a hole that was being created by human-made airborne chemicals called ozone-depleting substances. And the primary ozone-depleting substance was halocarbons. The most popular one was chlorofluorocarbons, or CFCs. And these are hydrogens and chlorines and fluorines and bromines, all of which are essentially stripping ozone of one of its oxygens and depleting it. Where does this come from? Where do these chemicals come from? They used to come from refrigerators, fire extinguishers, repellents from spray cans like hairsprays, and cleaners and electronics. Um, and Over the course of time, they started um, to realize that there was a particular issue. So this is how it happens. CFCs particularly are very non-reactive, and they were assumed to be safe. But once they're in the stratosphere, they can break down with UV radiation into individual chlorine atoms. And chlorine, if you remember from chemistry, is extremely reactive. It's a halogen, and it really wants an electron because it's so close to having its outer electron shell filled. So what it does is it takes away one of the oxygens from ozone. It makes oxygen gas. You might think, well, that's really good. Well, not so good. Ozone is different than oxygen gas. Not only is it a difference of one oxygen, but oxygen gas cannot protect us from UV radiation. So in 1985, researchers detected that an area of thinned ozone concentration called the ozone hole was formed every spring over Antarctica. And scientists were concerned that the elevated UV levels would increase the amount of skin cancer and damage plant life. What have we done? This is one of the great success stories of the modern environmentalism movement. In 1987, we had the Montreal Protocol, which was signed into action immediately. Countries agreed to cut CFCs by one half by the 1998. And over that time, as you can see, we see that the amount of CFCs have trailed off in the atmosphere. With the advent of different protocols, the Montreal Protocol, and then in London, then Copenhagen and Beijing, we have really seen a drastic reduction. We expect the ozone layer to be recovered by the year 2060. Why, you might ask? Well, if you go back to the previous video, we talked about resonance time. CFCs and halocarbons have a really long resonance time, decades, decades, decades. So it takes a long time for them to break down in the atmosphere. Acid deposition or acid rain is basically chemicals that form in the atmosphere to produce a substance that reduces the pH of the liquid in the atmosphere. And that can rain down and cause what we call acid deposition or depositing. Two ways that it occurs: we either have sulfur dioxide or nitric oxide getting into the atmosphere. And when those two things combine with water and oxygen, we get sulfuric acid and nitric acid, H2SO4 and HNO3. And that can combine with the precipitation and cause acid rain. We could also even have acid hail, acid snow. And what does this do? Well, Has many impacts. There's a long list over here. This is a visual representation or example of it. This is a picture of a talisman before and after acid rain. And you can see that the limestone, which is made of calcium carbonate, is washed away from this lower pH liquid getting on it. But we also see a lot of other problems, like leaching calcium from needles of red spruce, causing those trees to die, accelerating leaching of other ions like magnesium or sodium or potassium from the soil. It also allows sulfur and nitrogen to accumulate in the soil and can damage plants. What have we been doing? Well, we've definitely been addressing this. The Clean Air Act of 1990 established the acid rain program to fight acid deposition. As you can see, in 1990, we saw a huge drop off in the amount of sulfur dioxide emissions in the atmosphere. And also we have a program that's called an emissions trading program for sulfur dioxide, which basically it allocates permits for SO2 pollution and allows emitters to buy, sell, and trade those allowances. What this does is it creates a economic incentive to reduce emissions as well. As you can see, this is a great visual, 1990 to 2014. We see the pH slowly increasing over time, where the East Coast was down around 4.5, and now we see it more at like 5, 5.5. Indoor air pollution. Indoor air pollution is different than outdoor air pollution, obviously, and it has different sources. Many steps can be taken to reduce energy consumption, such as limiting ventilation, installing windows that are not open, as a result, worsen indoor air pollution. Particularly in developing countries, wood, charcoal, animal dung, and crop waste are used to heat homes or for cooking. And that concentrates the particulate matter or PM pollution in homes. Sometimes they can be as much as 20 times higher than the US EPA standards. Another form of indoor air pollution is tobacco smoke and radon. Those are two primary ones, particularly in this area. Smoking cigarettes can irritate eyes, lungs, throat, and can cause lung cancer and other forms of cancer. Radon is a naturally forming element and isotope that is radioactive, and it can cause, again, lung cancer. It's actually the second leading cause of lung cancer in the world. As you can see in this map, we have a lot of geologic radon potential, particularly in the northern part of the United States. And these are just from natural deposits in the ground, in the stone. When I was looking to buy my first home, we had to check the radon, and it was an expensive test, but it was a super important one. We had to make sure it was not too high. And many VOCs can pollute the indoor air. So laser printers, fax machines, and those things, and they can really affect our health. Respiratory problems, asbestos can be another problem from old buildings causing mesothelioma. And we can enhance indoor air quality in many ways: drying our wood before burning it, cooking outdoors, shifting to less polluting fuels like natural gas instead of coal or dung, installing hoods, chimneys, cooking windows to increase ventilation. If we're talking about developed countries, we should be reducing or stopping the smoking indoors, testing for radon and mold spores, and minimizing our exposure to VOCs. That's it.